So we are next going to start exercises 2.4, and let us start with the second one. Here we have to find the derivative of y with respect to x if y is 3 over x plus 5 sin x. So let's solve this. So in the solution we of course start straight away with dy dx. By the sum rule and constant multiple rule for differentiation, the derivative of this expression with respect to x equals 3 times the derivative of 1 divided by x plus 5 times the derivative of sin x. Now we already know this. This is minus 1 divided by x square. How do we know this? We know this from the power rule for negative integer exponents. This is x to the power minus 1. So if you differentiate this, it becomes minus 1 times x to the power minus 2. So that way you get minus 1 divided by x square, and we have 3 multiplied with that. So minus 3 divided by x square plus 5 times, what is the derivative of sin x? Now we know that it is cos x. So that way we get 5 cos x. Next let us take the sixth one. Here again we have to find dy dx if y equals sin x plus cos x times secant x. Now instead of straight away blindly going for the product rule, because you can simplify y. If you do the multiplication, what are you going to get? Sin x times secant x. Now secant x is 1 divided by cos x. So that means you are getting sin x divided by cos x. So that becomes tan x. And cos x times secant x is 1. So now you see that it's much easier to differentiate this, and in fact 1 is going to contribute 0 when you do the differentiation. So dy dx equals ddx of tan x plus ddx of 1. ddx of 1 is 0 and ddx of tan x is secant square x. So that way the answer is secant square x. Next let us see the 12th one. In the 12th one again we have to find dy dx, but this time y is a little long. It is x square cos x minus 2x sin x minus 2 cos x. So we straight away start differentiating. First dy dx becomes ddx of x square cos x minus 2 times ddx of x sin x minus 2 times ddx of cos x. So here we are using the sum rule, difference rule, constant multiple rule, all these things. And then we have to use the product rule. So this differentiation, this derivative will be equal to x square times ddx of cos x plus cos x times ddx of x square. Similarly, this one will be minus 2, of course, is there outside, x times ddx of sin x and sin x times ddx of x. And what is the derivative of cos x? Minus sin x. Never forget that the derivative of those trigonometric functions which start with a come with a minus sign. Okay, so that way it will become easier to remember. So minus sin x. And then next let's continue. So x square times ddx of cos x, which is minus sin x, plus cos x times ddx of x square by the power rule is 2x, minus 2x times what is the derivative of sin x? It is cos x. So minus 2x cos x, minus 2 sin x times ddx of x is 1. So this is minus 2 sin x, and minus 2 times minus sin x is plus 2 sin x. So you see that this and this term, they cancel out, because 2x cos x minus 2x cos x. Similarly, minus 2 sin x and plus 2 sin x give us 0. So we just simply have minus x square sin x. So that is the derivative. Next, let us see the 16th one. Yeah, let's see that. In this one, we have to find ds dt, where s equals sin t divided by 1 minus cos t. Still we have to differentiate, but the variable names are slightly different. And we are going to do this in two different ways. It's up to you to choose which one you want to write, okay, which one you want to take. So in the first solution, we are going to straight away start differentiation, and in the beginning itself we apply the quotient rule without thinking much about what the function is. So ds dt equals, you know the quotient rule, you have to square the denominator, so that's why we have 1 minus cos t whole square. Then you keep the denominator here and write the derivative of the numerator, which is sin t, minus, then you keep the derivative the numerator intact, and then multiply it by the derivative of the denominator, so d dt of 1 minus cos t. So then what does the calculation tell us? 1 minus cos t times d dt of sin t is cos t minus sin t times, now if you differentiate 1 minus cos t, 1 of course will give you 0, and derivative of cos t is minus sin t, but already there is a minus sign, so it will be plus sin t. And then if you do the multiplication here, you are going to get cos t minus cos square t minus sin square t. So let's continue. So the numerator becomes cos t minus 1, and in the denominator, in place of writing 1 minus cos t, you can write cos t minus 1 because there is a square. After doing the cancellation, you have 1 divided by cos t minus 1. So this is the derivative. Now in the alternative method, we are going to do something to the function itself first, and then we will differentiate it. So let's see. So in this alternative solution, we start with the function s, which is sin t divided by 1 minus cos t. And then what we do, we multiply and divide by 1 plus cos t. So then the denominator becomes 1 minus cos square t, the numerator just stays this for a while. And 1 minus cos square t is sin square t. So after you do the cancellation, you get 1 plus cos t divided by sin t. And then when you divide each term by sin t, what do you get? 1 divided by sin t is cosecant of t, and cos t divided by sin t is cotangent of t. And so ds dt will be equal to the derivative of cosecant t plus the derivative of cot t. And you write what these expressions are. Okay, I am not going to say anything more about that. But I will, however, say something. The answer that you get here obviously is going to look different from this one. So are we getting different answers depending on how we do the differentiation? Obviously that should not be the case, and actually that is not the case. Whatever you are going to get here is in fact equal to this. You just have to do some trigonometric manipulations to see how they are equal. That part I am leaving to you. Next. So next, let us take up the 20th one. Here we have again the variable names have changed. The independent variable this time is theta and the dependent is r. So we have to find dr d theta if r equals this 1 plus secant theta times sin theta. And here also we are going to first of all do something to the function itself, and then we will differentiate. So do something means you do multiplication. What else can you do? So simply you have sin theta here, and secant theta means 1 divided by cos theta. So sin theta divided by cos theta is tan theta, and that is why dr d theta is dd theta of sin theta plus dd theta of tan theta. This one is cos theta and this one is secant square theta. So that is your derivative.